Hi, my name is Vahid Jazayeri. I'm a software engineer from the real-time infrastructure team at Meta. And together with my colleague Pouya Zadkhast, we are going to show you how we built a stateful-looking PHP development environment as a distributed Lambda function for processing client-server interactions. Let me start first with the landscape of the problem space. In social network applications such as Meta, there's demand for live and interactive experiences. Users expect to see online indicator for their friends as soon as they become online. Or when they watch a live video, they'd like to see a stream of live comments, live reactions, typing indicators, and many other types of live data. These are just examples of types of data that has to be made live, or users will tend to reload the page in search of fresh and recent data. And we know that needing to do so isn't a good user experience, and it's not going to be efficient for the backend services either. But on the other side, making data live automatically isn't an easy problem, especially at Meta with several apps, thousands of use cases, and billions of daily active users. There are so many different products with distinct requirements. So a solution that works for delivering a stream of online indicators does not necessarily work for a problem like live video comments. Therefore, as an infrastructure team enabling products, we were wishing for an easy to develop and self-served environment for our product developers to implement their own applications and products without getting involved in the complexity of the infrastructure. And we were wishing for an easy environment such as a scripting environment in PHP. But that was not easy. So how did we solve this problem? By the end of this talk, I'm hoping that you'll learn more about this. So we are going to start with an overview of the state-of-the-art solutions and challenges, especially how we separated infrastructure and product logic that eventually paved the way for emulating a stateful-looking PHP web service. And then at the end, we are going to wrap up with the future works and the next steps of this solution. Let's start with an overview of the state-of-the-art solutions. To make data live in an application, the first and simplest solution that comes to mind is just periodic polling for the latest and freshest data, such as the latest comments, the latest notifications, latest online friends. This is going to be very easy to implement because on the client side, you just need a timer-based periodic poller that sends a request to a stateless server that eventually queries a database for the latest data. But the challenge here is choosing the poll frequency. Polling too frequently will lead to excessive resource utilization on the server side, as well as data and battery usage on the client devices. But on the other side, polling infrequently will lead to stale data, so a trade-off has to be made here. Alternatively, it is more ideal to push data in real time as soon as it happens to the clients. And for that, we need an infrastructure. A real-time push infrastructure that consists of three major components. One, you need a bidirectional persistent connection that connects the client to the server. Then on the server side, you need a stateful service that holds onto this connection and subscribes this connection to a subscription channel, also known as topic. For example, comments of a specific live video. Here I talked about subscription, so we need a PubSub infrastructure. PubSub refers to a service that exposes subscribe and a publish API. The stateful server uses the subscribe API to subscribe to a specific subscription topic. And then the source of data publishes new data, fresh data, to the subscription topic using the publish API. And then in here, the PubSub infrastructure is responsible for distributing the events and data to the subscribers. We built this infrastructure at Meta, and we called that Bladerunner. Bladerunner is the stateful service for processing real-time data for different applications. If you're interested, you can refer to the paper that we published in SOSP conference in 2021. There you will learn that Bladerunner is a more complex architecture than polling, obviously, but it immensely optimizes the efficiency both on the client and server side. In Bladerunner, we created a platform for different applications and product developers to implement their own data stream processors. And then Bladerunner would load and execute all these stream processors on the same server. But then different applications had their own custom logic from different data filters, data transformers, rate limiters, and so on. And at one point, we realized that, Bladerunner is actually running both infrastructure and product business logic at the same time on the same server. And that was complicating a lot of things for us. Code ownership was a challenge. It was hard to say what code is owned by infra, what code is owned by product. Product developers didn't have a good DevX experience because they were exposed to infrastructure code. Infrastructure engineers had trouble deploying different versions of product code on our own servers. And at the end, resource utilization was hard. It was hard to tell how much CPU or memory is attributed to infrastructure versus product business logic. So we had to find a solution to separate the infrastructure and product runtime environment. And we tried to solve this problem. How did we solve this? Pouya is going to explain more.
Thank you, Vahid. I'm Pouya Zadkhast, a software engineer in the real-time infra platform team, and also a Bladerunner developer. As Vahid mentioned, the coupling between the infra and product logic caused us multiple challenges. So we started revisiting the logics that products teams were using. At a high level, the products are either using a common set of logics that is shared across many products. For example, most of the products needs to subscribe to a PubSub service to receive server-side events, or they may need to limit the rate of delivery of events to their clients. There was also another set of logics that are more specific to each product. For example, the way that they do the privacy checks or data transformation to deliver the events that are suitable for different type of client devices, being web, mobile, or other type of devices. And with this separation, we decided to keep the common logic inside the Bladerunner and provide that as a standard offering that Infra provides for the products. We moved all the other logics that are specific to products to a different environment that is more suited for product development. And with this separation, Bladerunner really becomes a very lean service that is mainly driven by the product needs. For example, a product might need to subscribe to a PubSub service or terminate the client connections, and they're going to tell Bladerunner just to do that. And this brought us multiple advantages. First of all, the product teams and infra engineers can focus on what really matters to them. Products can just develop the logics that their clients needs, and infra are going to develop and maintain the logics that products needs without really worrying about what's going on the product side. We also have better capacity management because the resources that the products use are now measured in terms of the standard functionalities that they use inside the Bladerunner. So we have a better understanding of how much resources the products are using. And also we have a clear and transparent code ownership. The product codes lies in a different environments, is developed and maintained by the product team, and the infra code stays in the Bladerunner, and it is maintained and developed by the infra engineers. So we have a much clearer code ownership with this framework. Now, the next question was which development environment we want product teams to develop into. And at Meta, PHP is a very popular development environment, and it's been widely used by different product teams. PHP is a scripting language with great DevX. It highly relies on the RPC calls with very short memory lifecycle, which makes memory management extremely easy and very efficient. And over the years, because PHP has been widely used at Meta, ample tooling for code annotation, for CPU profiling, capacity management, and other capabilities have been developed for the PHP. So we picked PHP as the development environments for the product teams. And that brought us one step closer to emulating a real stateful PHP services for the product. And I'm going to hand it back to Vahid to further expand on this idea.
Thank you, Pouya. Yeah, let's see how we built a stateful PHP development environment. Those who are familiar with PHP know that PHP is stateless, and it's used to implement RESTful APIs. There is no support for persistent connections from clients, and there is no support for data streaming either. It's just a simple request-response model that device or the client sends a request to PHP environment to the server, and then in PHP server, we need to write a function to process this request quickly and return a response. And that has to be a fast execution, probably in a few seconds, or the request is going to time out. But this is too simple for us. It's not what we wanted. We were dreaming of a stateful PHP web server. What if there was a version of PHP in which a device could make a bidirectional persistent connection to the server, and then in PHP we could write code that hold on to this connection for as long as it wants and make a long-running subscription to different data sources. And then such an environment could have enabled us to introduce Lambda functions such as the one that you see in this code block, where the input is a connection, and maybe we can extract the subscription topic out of the connection parameters, and then we could access the pub sub layer right there to make a subscription to that topic. And for that subscription, we could register a callback, a publish callback, such that as soon as a data is published, we could process that data and deliver that processed data, that processed payload to the client eventually. But there is no pub sub access from PHP directly. There is no connection access directly in PHP. And we had to solve this problem. How? Again, we have to be realistic. PHP is stateless, but we thought that, okay, Bladerunner, which is a stateful server, can sit behind PHP and emulate a stateful PHP development environment. So in this model, still the connection and pub sub and subscription states are going to remain in Bladerunner. But then we had to introduce three concepts: events, lambdas, and actions, to make what we wanted. And I explain these three concepts in a few seconds. First, events. Events are essentially any triggers that is received by Bladerunner first, such as a stream request, a connection request from the client, or whenever the PubSub delivers fresh data to Bladerunner, this is again another event. But Bladerunner at this point doesn't process these events. Bladerunner delegates them all to PHP, to Lambda functions. Here is where we define a Lambda function for every event, and we let different application and product developers to implement them differently. But then the implementation in the Lambda is going to be limited by PHP. There is no access to connection or the long-running subscriptions, like I said. That's okay. PHP can return actions that are standard operations for Bladerunner to execute. They can instruct Bladerunner what to do next. Let me actually walk you through an example. Remember the same example of live video comments, that a bunch of users are watching a live video and then a stream of live comments are flowing to the viewers through our PubSub stack and Bladerunner stack. Let's see what happens actually with this framework. I'll walk you through the subscription flow first, that a user starts watching that live video. At this point, the device is sending a connection request to Bladerunner. And in that connection request, it specifically says that I'm interested in live comments for this specific live video. Remember that at this point, we have an event, a stream request event. Bladerunner delegates that to a Lambda function in PHP called onStreamRequest, where the input is actually the request and the response is an action for Bladerunner. What happens in this Lambda function, as you see here, the product developer actually implements it in a way that they extract maybe the video ID out of the request, and they create the subscription topic, such as comments of this video ID. And when it comes to subscribing, where they are limited by PHP, they create an action for Bladerunner, subscribe action. And in that action, they specify the topic they'd like to subscribe to. This action is returned to Bladerunner, and at this point, Bladerunner knows how to execute that action. It's a simple action of subscribe to the PubSub layer, and done. Bladerunner is now subscribed to comments of that video. And as you see here, PHP is still request response, but now it completed a subscribe action. Now, what happens on the publish flow? Everything starts from a user writing a new comment. Most likely, this comment is going to be persisted on the database on the back end. and the source of data decides to broadcast or publish this new comment to all the subscribers through the PubSub layer. And at this point, the PubSub layer delivers the comment to Bladerunner. Remember that this is a publish event. Bladerunner doesn't process that, delegates that to PHP. And now in PHP, we introduce unpublished Lambda function. The product developer at this point knows that this data is a comment, but it's a raw comment. Maybe they need to do privacy checks, localization, text formatting. These are all their product logic. We don't care as an infrastructure team. At the end, they create an action for Bladerunner to deliver this process comment to the user, because in PHP, they don't access the connection. And Bladerunner receives this action and exactly knows what to do. Bladerunner has already a connection to the client and uses that to deliver this comment to the device. So here I talked about PubSub features of this framework, but it's not all about PubSub. There's much more that we can build using this framework. And here I let Pouya explain to us what else this framework can enable.
Thank you, Vahid. So by now we should have a good idea of how the Bladerunner works with the stateful PHP server. And let's see what else this framework can enable us to do. So as we mentioned, the offerings that we have in Bladerunner has been mainly driven by the product needs. And we will continue expanding on these capabilities set as new requirements arise on the product side. For example, if the product needs to do a periodic polling, and for that they need a timer, they can start a timer action in the Bladerunner. And Bladerunner will periodically send the product side timer events. Alternatively, if they need to do the deduplication to avoid sending the same event to the PHP Lambda, they can also enable the deduplication in the Bladerunner. And so far, we've only talked about pushing server-side events to client. What if we want to send the client-side events to server? For example, in an application where the device logs are generated on the client device, and we need to send them to a data store, we have two options for that. Either send the logs as they are generated on the device immediately to the data source, which means we will be making a lot of calls to the data source, and it's going to be expensive. The alternative is to batch those logs on the device and periodically send them to the data source, which means we will be increasing the latency, and also we will be running the risk of losing those logs if the device were to crash or we were to lose the internet connection. Alternatively, what we can do using the framework is that we can open a stream from the client to Bladerunner. And we will be sending the device logs to the Bladerunner as soon as they're generated. And on the Bladerunner, we can batch those logs and periodically send them to a PHP Lambda. And PHP Lambda, in return, they can save it in a data source. And this way, we will be reducing basically the risk of losing those logs because they're sent to the infra side as soon as they're generated. And we will not overwhelm the data source by sending every log to the data storage. And we can also think about similar application and how we can leverage this stateful PHP and the streaming capabilities they offer. And with this, we can conclude our presentation. In a stateful PHP that we describe, product developers really focus on the product logics without really dealing with the underlying complexity of maintaining a stateful service. And Bladerunner provides us streaming capabilities that various products can leverage. Bladerunner receives the server-side events and sends them to a logic written in PHP, which we call it Lambda function. In return, that Lambda sends back a set of actions or instructions that tell Bladerunner what to do with the server-side event. And currently at Meta, Bladerunner is powering thousands of different products. And before closing this presentation, I would like to thank Tim and Sergey for the initial design and implementation of the stateful PHP, and also the whole RTI platform team for turning the ideas into reality. And I would like to also thank Anupama, Shilpa, and Shirvani for their valuable feedback and guidance throughout the process. And also thank you for attending this presentation. And in case you're more interested in learning more about the Bladerunner and its capabilities, we have a paper published on that, and we also have a blog post coming up. Thank you.